Look at Faraday's second law of electrolysis. Faraday's second law of electrolysis. What does it say? Now, it says that when you pass the same quantity of electricity, say A, through two different electrolytes, 1 and 2, Faraday discovered that the amount of substance deposited at the electrode will be inversely proportional to what? The charge of the ion. So when you pass the same quantity of electricity through two different electrolytes, the amount of substance deposited at the electrode will be inversely proportional to what? The charge of their respective ions. So that's what he discovered. Now we're going to be looking at an example. Calculate the volume of oxygen evolved at 285 Kelvin and 0.91 times 10 raised to power 6 Newton per meter squared, when a current of 2.5 amperes is passed through acidified water for 1.5 minutes. 1.5 minutes. Remember, molar volume of gas at STP is given as 22.4 dm cube, and 1 Faraday is equals to 96500 coulombs. So now, how do we go about this? First thing, solution. First thing, we are going to calculate the quantity of electricity. Quantity of electricity passed at 2 amperes for 1.5 minutes. Quantity of electricity is equals to what? IT. And this is going to be what? 2.5 times time, which is 1.5. Remember, your times will be in seconds, so you're going to multiply that by what? 60. And if you do that correctly, you should get 225. Alright, they say calculate the volume of oxygen evolved. So we're going to look at the anodic half equation for the evolution of oxygen. That means OH was oxidized to form what? O2. Are you following me? OH was oxidized to form O2 plus what? H2O. We need to balance this equation. If we put 4 here, and then we'll put 2 here. I think this equation is balanced. Plus 4 electrons. Now, 1 electron evolved is equals to 1 Faraday. That means 4 electrons will be equals to what? 4 Faraday. And that is 4 times 96500. Alright now. Now, at STP, 4 Faraday, that is 4 times 96500 of electricity yielded a volume of 22.4 dm cube. Now, at this quantity of electricity that we calculated, 225 coulombs will yield what? Now we'll cross multiply and get the volume here. What we use is going to be what? 225 times 224, and that will be equals to what? 225 times 224 divided by 4 times 96500. Please, can you press your calculator and give me the answer? Press your calculator, let's have an answer. The volume is going to be 13.06 cm cube. That is not the final answer. That is not the final answer. They say calculate the volume of oxygen evolved at 285 Kelvin and what? 0.91 times 10 raised to power 6 Newton per meter squared. What I've calculated is at STP. Let's calculate for this temperature and this pressure. Are you ready? Let me get that volume. We're going to use the general gas equation. We say P1 V1 all over T1 will be equals to what? P2 V2 all over what? T2. From here we can make V2 the subject of formula is going to be equals to what? P2, if you cross multiply, you get V2 will be equals to P1 V1 T2 all over P2 T1. Now let's get our details. T1, okay, P1 is equals to standard pressure, and that's going to be 1.10 times 10 raised to power 5 Newton per meter squared. What else do we need? T2, T1 is a 273 degree Kelvin. V1 is 13.06 cm cube. We're left with P2 now. P2 is a 0. This 0. P2 is a 0.91 times 10 raised to power minus 5. Sorry, it's not 6, so it's raised to power minus 5 Newton per meter square. Correct it from the question. It raised to power minus 5. And then T2 is equals to 285 Kelvin. Now we are looking for what? V2. Now V2 will be equals to, let's substitute this. P1 is a 1.01 times 10 raised to power 5 multiplied by V1, which is 13, multiplied by T2, 285. We divide all of them by P2. P2 is a 0.91 times 10 raised to power minus 5 multiplied by T1, which is 273. All right, now, please can you help me press your calculator? What answer do you get? If you press your calculator correctly, what did you get as the final answer? You are going to get 15.13 cm³ as your final volume of oxygen evolved at 285 Kelvin. Is that okay? Now, if you find this interesting, if you understand it very well, give me a follow, like, share, and comment so that you get updates whenever I post new videos. You can also go through my page for intensive lessons, over 100 lessons already on the page. Let's move to the next class.